Let's explore TinkerCad. Hello, welcome to TinkerCad. We will use this platform to learn how to design and simulate electronic circuits. This is also the best way to learn how to design and program your Arduino projects even if you don't have a physical Arduino board. Let's start by creating a new circuit and exploring the user interface. We do that by clicking the Create Your First Circuits design. This is the TinkerCad Circuit Design User Interface or UI. First, let's change the name of our circuit. You can find that on the upper left corner of the screen. Let's name this My First Circuit. This area is the work area. This is where you will work on the components that you need. On the right is the Components panel. You will find here the components you need for your electronic projects. On the upper right of the screen, you will see 3 different view modes. By default, you are looking at the circuit view. Next is the schematic view, followed by the components list. The schematic view will display the schematic diagram of your circuit, and you will see the components used in the components list view. Below that, you will see the Code panel. This is where you will write the code for your Arduino board. Now let's add a breadboard. A breadboard or perf board is a convenient platform for prototyping electronic circuits. With a breadboard, you can easily build a prototype of your circuits without soldering. Moreover, it is easily changeable when testing new configurations. To add a breadboard, simply click the breadboard from the component panel, then click on the work area. Let's name it Breadboard 1. Click the Zoom to Fit button located at the upper left corner of the work area to center the breadboard. Let's have a quick look at the breadboard. Looking at it horizontally, the top and bottom strips are called buses or power buses. They are marked with black and red lines. At the end of the lines, you will see a negative and positive sign respectively. These indicate where you connect the respective terminals of your DC power source such as the battery. The red line indicates that the holes adjacent to it are for the positive terminal of the power source. Thus, this is commonly called the positive strip. It follows that the black strip is for the negative terminal and is called the negative strip or the ground. As you can see, when you hover the mouse pointer over one of the holes, the rest of the holes in that line are highlighted, which means these holes are connected. The middle of the board is the component area. In most breadboards, this area is labeled by letters for the columns and numbers for the rows. These letters and numbers indicate the location or coordinate of each hole. Hover your mouse pointer over the hole A2. You will see that the holes from A2 to E2 are highlighted. Just like in the power bus, this shows that these holes are connected. Meaning, if you insert a wire at A2 and another one at E2, they will be connected. If you want to know more about breadboards, please check the link in the comment section. Adding the battery and connecting it to the breadboard. Now let's add a battery. Select the battery from the component panel and add it to the work area. Press F on your keyboard to fit everything on your screen. To connect the battery to the breadboard, click on the positive terminal of the battery, then click on one of the holes of the positive power strip. Then connect the negative terminal to the ground. The colored lines represent the wires. It is a common practice that the wire that is connected to the positive terminal is red, and the ground is black. Thus, it is best to change the color of the wires accordingly. Let's now add our first component. A light emitting diode or LED. Since a LED is a type of diode, it allows the current to flow in one direction only. Thus, you need to connect the anode to the positive terminal of your battery and the cathode to the ground. If you need to know more about the LED, please check the link in the description. Go ahead and connect the LED to the battery as shown. Insert the cathode or left leg of the LED into hole E4 and the anode into E5. Then connect A5 to the positive strip and A4 to the ground. Then click Start Simulation when you are done. As you can see, the simulation shows that you have broken your LED. This is because the LED is rated at 5 volts only and we connected it to a 9 volts battery. I wanted you to see what can happen if you put too much power into an electronic component. To prevent this, you need to connect the cathode to a resistor first, then connect the resistor to the ground. If you want to learn more about resistors, please check the link in the comment section. Go ahead, try this new configuration and click simulation. If you got it right, you would see the LED light up. Congratulations! You have just successfully created your first electronic circuit.